some hint related to all these questions. So first question says at a distance 400 meters from a traffic light, brakes are applied to a locomotive moving at a velocity given. We need to determine the position of locomotive related to the traffic light 1 minute after the brakes have been applied. So what you can do is you just draw a picture. Assume this is a traffic light. So with respect to traffic light, that means that is the observer, and this is the locomotive which is moving with initial velocity that is given to you. So this velocity is given to you as a 24 km/h. Convert it into meter per second because we need to consider this in meter per second, and we can give our answer in meter per second. So this is the scenario at t equal to 0. Initially it was 400 meter from this, so you will write this is 400 meter, and as time passes, let's say after 1 minute it reaches at this location, so this is a t 60 second. So in place of t we are going to use 60 seconds, and we need to find how much this distance is going to be. So let's say this travels as distance. So basically answer is to be stated as this. Let's say this is x. So can we say x is going to be the total distance, which is L minus S, the distance that it has traveled during this braking or during this retarding process, right? And how this S can be calculated? Use the equation second. S is equal to ut plus half at square. Now you got to know t as a 60 second, a as a minus 0.3 meter per second, and t is given, u is a 54. So you can convert this u into meter per second, and then you can put solve as, and then solve this L value, L minus S, so x value, so that x will become your final answer, right? Now consider this question number 2. This question number 2 will be solved like this. It says a particle goes from A to B with particular velocity or speed, from B to C with another speed, and the relation between two distances are known to us. We need to find the average speed, so hint has been given to you. Average speed is the total distance upon total time, so find the total distance and total time. Then you will get your answer for the question number 2. Now let's go for the question number next, which is third. It says an object moving with uniform acceleration, so it's a constant acceleration case, with has a velocity this in the positive x direction. Its x coordinate is this, so that's the initial position. So it's not starting from origin, so that's the initial position. If its coordinate is this, 2 seconds later is this, what is the acceleration? So here the initial position is not 0, so you write as x initial as this initial, that is 3. And x final, this x final has to be written as minus 5. So the displacement covered, that we call as a s or x, this is going to be final minus initial, xf minus x initial. This is how you need to write. So you need to use this s, that is displacement, as this minus 8. Now use this displacement as a minus 8. And what else you have been given? The time taken for this process, so you got to know t, right? And then what else is given? Initial velocity is given, so you got to know initial velocity as well. And you can use the formula s is equal to ut plus half at square. From there you can calculate the acceleration for this particular case. Question number 4, you can read the question. It says we need to find this sign of V0 and A. So particle is said to be 5 meter on left, so it is on this left, and it is moving away, so it's moving in this direction, so that's a velocity direction, and it is having a velocity over the time which is reducing, right? So slowing down, it is slowing down. That means A must be acting in this direction. It's going to be retardation, right? So for a retardation, both must have opposite directions. So this is how you can decide the direction, sign of V0, which is negative, sign of A, which is positive. Question number 5 is a good question. It says velocity time graph is given to us, and rate of acceleration and deceleration is given, that is a constant, that's a 5, and average velocity during the motion, entire motion up to 25 seconds, it is 20 meter per second. We need to find t value. So this is 25, right? So we got to know the total time taken, and this is going to be well, if it is t, that means this is t entire time, right? And since acceleration and deceleration are equal, and we know the slope gives us the value of acceleration and deceleration, that means this slope and this slope is going to be identical. Peak value is also identical, so you'll find if this is a t, so this is also going to be t. That means this coordinate could be written as 25 minus t. And if you got to know this, and you can think of this as v0, we need to find the value of t from it. So we can apply the formula v average. V average is equal to the average value that we are looking for. So the average velocity is total displacement by total time. Total time is 25. Total displacement is the area. So you can directly write it as 20 that you need to write as average velocity. It must be equal to area. Area of this graph, or area under the graph, divided by total time. Total time is 25. So this is time, and this time value is 25. When you are calculating this area, then you will find you need to write this area, and this area, simplify it, and from here you will be finding a relation between v0 and t, because there are going to be two unknown. v0 is unknown and t is unknown. And one more relation we can find from this slope. Slope of this is going to be 5. So another equation is slope 5 is equal to this perpendicular, which is v0 divided by t. You're getting this? So this is coming from the tan theta. If it is angle theta, so tan theta is perpendicular by base v0 by t, and that has been given as a 5. So using these two, we will get two equations, and that can be simplified to get v0 as well as t. In this question number 6, a figure has been given for v versus t, and it is asking the time when the particle returns to the same point, starting point. That means it wants displacement to be 0. So you need to make the displacement 0. And how to calculate the displacement in v versus t graph? It's area. So you can measure the area of this triangle and keep it in the forward direction, and measure this area. Let's say it goes somewhere there. That has to be straight line, right? So you need to draw the picture properly. And if you go for that, so this is going to be straight line like this and this. You assume this t that you are looking for. So the area upside is taken as a positive, area downside is taken as a negative. So you will find this total area must be 0. That means upside area must be equal to downside area. So at what time this downside area will become same as this? That's what we need to find. For that thing, you need to do some geometry. That means this is straight line, so having the same slope. So you can find this slope of this downside one, then you can extend it downside, and you can also measure at what velocity it happens. So you can solve from this, or at least you can say when you calculate the area equal, so you will have a two unknown. One is this t, another is the v that you are going to assume over here, minus v0 or something, and another equation you can get from the slope. Just like in the previous question, you will be able to answer this one. Okay, and that is sufficient hint, I think. Yeah, if you just follow, you will get your answer. Question number 7, it says a rifle with muzzle velocity. You might get this kind of term, muzzle velocity. Muzzle velocity means the velocity of the bullet with respect to the barrel. So when you fire a bullet from a gun or rifle, then whatever the velocity of that bullet comes out with respect to barrel is called muzzle velocity. And it is targeting a small target that's some 30 meters away in the same horizontal level. So let me draw a picture for this. That is same horizontal level, and here is the target. That's a target, and from here you are shooting it. So this must fall on this, hit on this. That's what the target is. This angle is theta, and what is given to us is the distance. That means r. Range is known to us. How much the distance this is? This has been given range as a 30 meter. Okay, I hope you are able to read this fonts. So that's a 30 meter, and it is asking how high one should target in order to hit this target. That means we want this target to be hit. So let's say if you are having this angle theta, so that means rifle is having target somewhere there. This height we need to find out. This height. And how we can find that height is simple. First use this range formula and find theta. Once you get theta, so you can write tan theta from that triangle. If you look at that triangle, is going to be h divided by r. Now you got to know this r, you got to know theta, and you can simplify for h value. Moreover, it says small angle approximation. In case of small angle approximation, you'll find this is going to be approximately equal to sine theta. So what you can do, you can find sine theta and equate it with this tan theta, because sine theta and tan theta, they are approximately equal when theta is small. So this approximation will avoid some calculation and make it simplified, and you can find it out after solving this. Now let's focus on this question number next, which is 8. It says a man can throw a stone with initial velocity given to you. Find the maximum horizontal distance which can be thrown the stone in a room which is having a h height. So here in this question, height is limited. So what do you need to do for the first part and for the second part? First use this h value, find theta. Right. And if theta is coming less than 45 degree, then whatever is theta, that theta will give you the maximum range. But if theta is coming more than 45, then answer will be 45, because the range is maximum as a 45. So what you need to do, find theta, check theta if it is less than 45, so whatever theta is, that is your answer. And if theta is more than 45, then answer is not the theta, but that angle should be 45. So range will become R max. Are you getting my point? So from here you say angle of projection, if it is less than 45, so angle of projection will be theta. Now use this theta to find the range, and if you get theta more than 45 degree or particular value of height given, then in that case use 45 as your theta. So if it is more than 45, let me write over here clearly, 45, then angle theta will be used as a 45. That means in that case, actually what the maximum can be achieved, that will be achievable. So use theta as 45. Now for question number 9, you can go for comparing this with the equation of trajectory, which is y is equal to x tan theta minus gx square upon 2u square cos square theta. Compare, find theta as well as velocity. For question number 10, what we can do is this. It says after 2 seconds, its velocity makes 45 with the x-axis. That means the two velocities becomes identical. So what we can have this kind of projectile, and this is going like this. And then we can say this is the situation when this happens. So there will be vertical component of velocity and there will be horizontal component of velocity. This horizontal component velocity remains the same, that is u cos theta. And this is the vertical velocity. Can we say when they are the total velocity is making 45 degree, that means the two components must be equal. So we will use this condition Vy is equal to u cos theta. However, how we can calculate this Vy? How we can calculate this Vy? By using this u sin theta minus gt. That's the basic formula. And t has been given to you, g you know, theta, u they are unknown. And this Vy is also u cos theta, so that will be in terms of u and theta. So this will give you one equation. Another says after 4 seconds, this is when the t is 2 seconds. After 4 seconds, it reaches to the highest point. So at t equal to 4 seconds, it is at the highest point. That means u cos theta is total velocity, and this is at the topmost point Or we can say simply that this time that we are talking about, 4 seconds, is half of the time of flight. So this is basically t by 2. And we know this t by 2 is equal to u sine theta by g. U sine theta by g. So from here you can calculate another equation, or you can find another equation, that is u sine theta by g is equal to 4. So u sine theta, if you are looking for this, so this u sine theta is equal to 40. Now you can place this u sine theta over here. G is 10, this is 2. So from here you will get calculate this u cos theta. So let me write that as well. So that will become u cos theta is equal to u sine theta is 40 and this will become 20. So that will come out to be 20. Now you got two equations between u and theta. What you can do, you can square and add to find the value of initial velocity. When you square and add, you will find theta will get eliminated immediately. Question number 11, similar type question we have already done, in which we have talked about the final velocity becomes perpendicular to the initial velocity. So you can use that formula directly. What need to be taken care of this, that this theta is 60 degrees from the vertical. So in projectile we use theta from the horizontal, so it will be 90 minus 60, that is 30 degrees. So you need to use this, and taking care of this you can find the answer. Question number 12, it says a projectile has been thrown from a height and we need to find that height, as well as we need to find the initial speed, and it hits after 5 seconds at this angle. So you can make this kind of picture, rough picture. Let's say this is a height and this is a ground. You have thrown like this. So we need to get two components of this velocity. So this is the velocity, let's say u, that u has to be found out, and this is horizontal direction. This angle is theta, which is 30 degree given to us, and this projectile will be following like this and hitting like this. If it hit at 45 degree, that means horizontal component and this vertical components, they are equal. You will find this horizontal component does not change, so this becomes u cos theta, cos 30 degree. This will remain the same over here as well, which will ask you to say, because that's 45 degrees, so this component must be equal to u root 3 by 2. Makes sense? And this is going to be the initial component of velocity, that is going to be u by 2. So now you can use the vertical motion. This is the initial velocity in the vertical direction. This is the final velocity. Gravity is downside. T is given to you. So equation of this Vy is equal to initial velocity, that means Uy minus Gt, or plus At basically. So I'm writing as a minus Gt. So here this is also come with a minus sign because this final is a negative direction. So it will be equal to basically minus u root 3 by 2 is equal to, initially it is u by 2 minus g, which is 10 you can write, and the t, which is 5, so you can write it as a 50. You can solve from here and the second part will be done. Once you are able to do the second part, then you can find the height by using the second equation, h is equal to ut plus half at square, writing the proper directions. Makes sense? Now let's come to the next question, that is question number 13th. It says a figure is shown over here. What should be the initial speed of the left side projectile so that they hit in the mid-air? That means they must be colliding. So relative velocity of 1 with respect to 2 come like this. For that thing, the condition comes out to be that the vertical component of velocity of the two must be equal. So you can find the vertical component of this, and you can find the vertical component of this. That is going to be u sine 60. And from here, this vertical will be 20 sine 45, isn't it? So now you need to simply equate these two. As you equate, you will find the value of u, which will cause for collision in the mid-air. Now let's talk about this question number 14. It says a ball starts from rest, accelerates this while moving down an inclined plane, this meter long, reaches bottom, rolls up another plane and comes to rest. So you need to draw a picture. You can draw this kind of picture. So let me draw this kind of straight line. This is one inclined plane, this is another inclined plane, and a ball is coming down from here maybe, and this distance, the distance is given to us. How much it is rolling? 9 meter. What is acceleration in this direction? That is given to us. Let's call this S1. This is A1. Initial velocity is 0. And when this is smooth, we will consider this is so smooth that it is not changing the velocity. So when it hits this or comes to the ground, we can find the velocity, we can find the time. Then it rolls up on this part and goes up to this height. So that means this S2 is given to us. That's a 15 meter. And finally it becomes at rest. That is also known to us. So that's a one straight line motion. This is another straight line motion. And whatever this acceleration is given to you, this is a complete no need for gravity, because this is a total acceleration that is given to you. And we need to find the speed of the ball bottom of the first plane. So let's say this is V dash that we need to find, or V1 you can call it. So we can apply the equation. What A is given, S is given, initially velocity is given. So you can use a third equation for this. So equation third will solve this. How long does it take to roll down in the first plane? So use the first equation. V is equal to U plus AT. A is known, U is known, T can be calculated. So first equation. Acceleration is in the second plane. Now we need to find the acceleration in the second plane. Whatever this velocity V1 is coming, we will consider this as a initial velocity for this case, because we are assuming it's smoothly going there. So the same velocity will act as an initial velocity. And then you can consider this acceleration is A2. Rather it's going to be retardation, but you take it this way. So A2 will come out to be negative. And if you take downside, it will come out to be positive. Again, use the third equation, because this is using the displacement, final velocity, initial velocity. A2 can be calculated. Right? Since it is asking as acceleration, then we need to find, we need to say this with a minus sign as well. Then finally it says ball speed of moving through 8 meter up in the second plane. So 15 up to it goes. If it is asking for this, you can still solve. Let's say it's the V dash, and use the displacement, use the initial velocity, use the acceleration, third equation, you will find it. Because acceleration is a constant, so that's a simple question. Okay, I described how to solve. You can solve that and check your answer. Question number 15. This question number 15 is a ball is projected on a smooth inclined plane in a direction perpendicular to the line of greatest slope. So that is the line of greatest slope. And perpendicular to this, that is in this way 90 degree it has been thrown. Find its speed after 1 second. So that's a projectile. If you throw like this, so how the projectile is going to go? It's going to follow this way. Right? And this is a plane. So what is important here? You can say there are two directions we need to work upon. You can think of this is your x dash direction, and this direction is downside is y dash. So that's a two-dimensional motion. What you need to find is acceleration in the two directions. So let's say this is, I'm plotting with another color, and this is the path. So what is going to happen? First of all, gravity acts downside. So this gravity will have a one component along the inclined plane. Can you see that along the inclined plane component? This is 37. So we know this comes out to be G sine 37. G sine alpha. This is alpha. So along the inclined plane, it's a G sine alpha. So downside, there is going to be acceleration called G sine alpha in this direction. And this component, which is horizontal, will remain unaffected. That means there will be no acceleration in that direction. So you can solve this two-dimensional motion. Just consider this acceleration downside. That means this is the acceleration in AY this direction. And that is equal to G sine alpha. Alpha is given to us, G, you can simplify it. You need to find the speed after 1 second. So after 1 second, you will find this horizontal component of velocity will remain the same. That is, Vx will be same as 8 meter per second. What do you need to find? What the velocity comes out to be in this direction. So for that sake, you can calculate Vy. Vy is going to be equal to initial velocity in that direction was 0 plus A into T. A can be written as G sine alpha. That means G sine 37 degree, and T is 1. So that's the Vy. That's the Vx. Square under root, you will get the speed at that moment of time. Now let's move towards the next question. This next question is 16. It says find the range of the projectile on the inclined plane which is projected perpendicular. So it's perpendicular, right, to the inclined plane with velocity. There is as shown in the figure. So you can use the equation of inclined plane motion. You are throwing it downside, so use those equation for downside. Take this as a reference. And this theta that we measure is given as 90 degrees. So use theta as a 90 degree. And alpha is given as a 37 degree. Use the equation of projectile on inclined plane for downside and simplify it. You will get the range out of that. Okay. So this is a hint about the question number 6. So now let's talk about the question number 17. It says a ball is thrown horizontally on the cliff. So this is the horizontal velocity you are using for the ball to throw. And after 5 seconds it hits, this is given to you. So you can think of this as an inclined plane, right? And you can use the motion of inclined plane. And this is alpha. Alpha is 37 degrees. And theta is also 37 degrees. So you can use that thing. Or you can say this is the time of flight is given to you. And I have told you that the time of flight is going to be 2 times u perpendicular divided by g perpendicular. Now what is the u perpendicular? That means perpendicular component. That means this component. This is 37, so you'll find this component is going to be sine 37, so that's a u sine 37. Use this as a perpendicular component. And what is the g perpendicular? G perpendicular is a g cos alpha, so that's a g cos alpha. This is a g sine alpha. So you simply use this. T is equal to, that is 5 is equal to twice u sine 37. It will give you answer quickly. Divided by g cos alpha, which is cos 37, and you can say that's a tan 37, and then g is given to you. You can find the value of u. Question number 18. It says a rocket is launched in a particular direction, so you can make a picture. Let me draw the picture, then you can solve this by your own. So let's say you are throwing a rocket from here, so that's the rocket is being thrown. So it got acceleration, so it's moving a straight line, and it moves in a straight line up to 3 seconds. So first 3 seconds you consider this a straight line motion. For that, initial velocity is given to us and a is given to us. Once this particle goes, or satellite goes here, or this rocket goes here, then after that its engine is off. That means it's free falls, so it will got a certain velocity at this instant of time. This velocity will be behaving like a projectile velocity, and then it will be moving like a projectile downside. So you can find what this height is. So second journey will be projectile from a height. You can find this angle remain the same angle as it was thrown with. And what we can be, this v will be different. V can be calculated by using equation v is equal to u plus at, because the acceleration is a constant and time is given to you. So you can find the projection velocity. Then after we need to find certain answers, and you can answer them. Just like the first is maximum altitude reached by the rocket. So you find this maximum height. That's h, but this is not the answer. Maximum altitude is going to be the entire one, including this h. So h plus s will become your answer. This h can easily be calculated. How? Because you know this theta. You can find what the distance is. So this is a right angle triangle. You can solve for h using trigonometry. Time of flight, total time of flight. So first you need to find this time. That is given to you for 3 seconds. And then you need to find this time that it takes to come down. Of course, it's going to hit on the ground back, right? So it's going to be hitting the ground back somewhere there. So that is what the total displacement unit, total time of flight you need to find. So this time is given to us 3 seconds, and you can find this time of flight for this by using the vertical component of motion and horizontal component of motion. The displacement is basically this much, and you can find the t value. Horizontal range. For horizontal range, you can find, again, do this calculation when you're computing this x component. Then you can find this is going to be x is equal to u, or this component, horizontal component, that is v cos theta, into the time of flight from this location onward, right? And this you can already find by using triangular property. So horizontal range will be calculated. Makes sense? Question number 19. It says a stone is dropped from a height h. Simultaneously another stone is thrown from the ground, and that can go up to 4h. Find the time when they are going to cross. So that's a simple question. but still I'm going to tell you the figure. So that is being dropped and that is being thrown. Let's say it is being thrown with velocity u, and this total gap is h. You have understood the relative velocity, so let's say this is 1, this is 2, you can work with respect to 1. If you are working with respect to 1, then you'll find 1 will find itself in rest, and the relative acceleration will be 0 because it's also gravity, so relatively they will be subtracted and cancel out each other. That means it will be moving with a uniform velocity. So this must go here and meet it to this. So how long it takes? It takes h divided by u, distance divided by the velocity. This is the time when the two particles are going to meet together using the relative velocity. Now what is this u? U can be calculated by using this information. That means this particle can go up to 4h height. So that means 4h is the maximum height when you throw with the velocity this, and you know this is u square by 2g, isn't it? So u square by 2g is the maximum height formula, and you can find u from here, substitute here, you can find the value of t. That is the time taken to meet the two particles. For question number 20, it says a balloon is ascending vertically with acceleration is given to you, and stones are being dropped after 2-second time interval, and we need to find the distance between the two. So you start like that. This is initial position of this balloon, and when it was moving with velocity u, it released the first, and then it goes up with that acceleration, and its velocity will become some different v after 2 seconds when it released the another one. So when this particle was released, and so this particle will be moving, starts moving at velocity u, because we know it takes the same velocity. This is the scenario of t equal to 0, and this is the scenario when the time was let's say t equal to 2 seconds after. So it is releasing another particle. So this another particle will be moving with velocity v. Then we need to find the distance between the two after certain time intervals. So we can take this as our reference. And that time interval is set 1.5 seconds. So this has to be traveled for time 2 plus 1.5. That means we need to find in 3.5 seconds how much displacement it caused. Then we need to go from this and to give time it for 1.5 seconds. We need to find the displacement caused by this in 1.5 seconds. Let's say h1 is the displacement of the first from this location in this time. This is t1 time. So this is going to be u t1, this is upside, minus half g t1 square. Now you find that t1 is known to us, g is known to us, u is something that is unknown, and that we are considering the initial velocity from where this dropping is starting. Now let's talk about the second, and the second will be having displacement from its own position as v into t2. t2 is 1.5 minus half g t2 square. Makes sense? Now v will be connected with this because this balloon has gained this velocity v with that acceleration which was given to us. So v and u can be connected by another equation. That another equation going to be v is equal to u plus a, which is given to us, into t. T is going to be that time, which is 2 seconds. So t is a 2 seconds. So we use this t. We can find this v and u up. They are related together, so we can replace this v by u. So we will get two equations in terms of u. Then after, we can say if it is rising by certain height, displacement, and this is also having some displacement in the upward direction, and this distance we can measure by using the balloon equation. S is equal to ut plus half at square. So there's going to be two main equations that we need to apply. T is again 2, so that we got this value. Now we can easily find out the separation between these two. So what that separation between these two particles is going to be. So we can measure from here. We can say this is s distance height above, and then that is h2 height. So can we say this h2 plus s that we have calculated? It is the height of the, or the location of the second particle from the ground or from this reference line. And this has to be subtracted by this thing h1, because this has gone also h1 upside. Now this h1 and h2, they can be positive or negative whatsoever, but we need to find this. This is going to be the separation between the two particles at the moment 1.5 second from the second stone was released. How I have calculated this, let me tell you again, because this is s distance and this is rising up for h2. So this location will be h2 plus s. This is rising by h1 total. So this is h1. So out of total, if we subtract this, we are going to find the separation between the two locations or two particles that was needed. Okay. Now let's talk about the question number 21. It says glass wind screen whose inclination can be adjusted in a car, and that car is moving at 2 meters per second. Angle alpha we need to find from the vertical, so that the wind screen finds the perpendicularly coming the raindrops which were actually coming vertically downside. So you read it, you will understand. So let me explain what is going on. So raindrops are coming vertically downside. So I'm making a picture for raindrop, and they are moving downside with a velocity. Raindrops falling vertically down with velocity 6 meters per second. So that is given to us. And let's say car was moving in this direction. So with respect to car, so that is being drawn with respect to car. And assuming the car was moving towards east, so this will be giving the velocity in the opposite direction. You know, with respect to car, the velocity goes in opposite direction, that is 2. So the resultant velocity will be coming somewhere there. So raindrops will appear for the car driver coming like this. And hence the wind screen has to be adjusted in such a way so that it appears perpendicularly. So the wind screen has to be made like this. Right. And we need to find what the angle from the vertical, this has to be bent on. So let's say this is a vertical, this is a horizontal, this is the wind screen of this car. So this angle is alpha. That means angle alpha from the vertical, that's what it is asking. Alpha from the vertical should be made so that this hit the wind screen perpendicularly. So this is striking it perpendicularly on the wind screen. And that's the velocity of raindrops. Makes sense? Now we need to find this alpha. So can we say if this is alpha angle, so this is 90, this is 90 minus alpha, so this will become alpha. If this is alpha, then you'll find simple equation tan alpha is going to be equal to, that's the resultant direction from this vector 2, thus becomes 6 by 2. That is basically 3. So we can say alpha should be equal to tan inverse 3. And that's your answer. Now let's come to the question number next, which is 22nd. It says two particles are moving along this straight line and in the same plane, and the speed are equal, 20 centimeters per second, angle 60 degree is given between them. O is the intersection point. At a given moment they are located 3 and 4 meters from O and moving towards O, shortest distance, subsequent motion we need to find out. So let's draw a picture. So that's the one line and this is another line. They are at 60 degree. So this is intersecting point O. So for intersecting point O, they are moving towards this. There are two particles. So let me draw those particles. This is, let's call 1, which is moving here. And that velocity is given to us 20. Both are having 20. So initial distance is given to us. This is L1, which is 3 meters. You can find it out. And another is this, which is again moving towards this origin with the same velocity. So this is also V, this is also V, and this distance is L2. And we need to find things like shortest distance and between these two. So with respect to 1, we will work for the second, right? So if we go with respect to 1, so first of all we can find this distance. Can you find this distance? Yes, we can easily find, because this angle is 60 degree. And if this angle is 60 degree, and you will find that L1 is known to us, L2 is known to us, so this can be found. Then we can also find this angle as well as this angle. So everything for this triangle can be calculated. then what you need to do is come with respect to 1. So let's say with respect to 1. I'm giving you just idea. You can work on this. You will get it. Definitely. So with respect to 1, so this 1 is going to be at rest. And its velocity will be given to another one. So this is the second particle which was moving in this direction with 20. It was given to you. And this angle we know. Let's say this angle is alpha, this angle is beta. We can find these alphas and betas. So, and this will have a 2 component, or you can simply say that if I draw like this, which is making 60 degree with this, because they are intersecting at 60 degree, right? So this velocity, another velocity will be coming like this. This is another velocity. And now you got these 2 vectors, then you can find resultant of these 2 and find the resultant direction, right? And once you get the resultant direction, then you'll find, let's say resultant direction is coming here, maybe in this direction. I'm just giving you an idea. So you can find what this angle it is going to make from this direction. For that sake, you can make the component of this. You can also make the component of this. So everything will be settled down like total component in the x direction, total component in the y direction, some sort of this. Then the resultant will be, that means the particle will be moving like this. And then after what you can do is this, because this point 1 is known to you, and this was point 2. That means this is the velocity that is coming off point particle 2 with respect to 1. If it is coming in this direction, then it will be coming to this, so shortest distance will become 0. If it is making certain angle, so let's say this angle it is being made, and you have already understood, calculated the 1, 2 distance, then after the next point that you need to perform is this, you just draw a perpendicular to this, because the shortest distance is always perpendicular distance. You need to find this as your answer in the subsequent motion. Now, this can be calculated by using this resultant velocities. And once you are able to measure this, and you have measured this is a right angle triangle in which one side you know, one angle you know, so you know the another angle, or you can use this sine stuff to find this value. Right. So this is basic idea. You work upon it, you will get your answer. Okay. Question number 23 is based on crossing of a river, and it says river is being crossed. So minimum time. So you say minimum time formula is T minimum is equal to this width divided by velocity of boat in the river, and this T minimum is known to you, and what else, for this case theta came out to be 0, because you need to move directly in that case. And in this particular case, drift has been given to you, so you can say drift, which is 120, we used to write as x, it is Vx into T. Vx is, if you remember this, Vr minus Vbr, and this sine theta into T. So that is given to us as a 120 meter. Now theta is 0, you place here 0, so that term will become 0. This is Vr, and T is the T minimum that is known to us. So in this expression, you will find that T is given to us, this becomes 0. From here you will be able to find Vr. So this will give you the velocity of river. Equation number 2. And from the first you will get a relation between these two. Then this says it crosses the river, shortest path. Shortest path is that drift has to be minimum, and since this velocity of boat in the river is higher than the velocity of river, so minimum drift will become 0. That means this is a width. This takes for this time. So that means in that case, which angle for the shortest path case, you remember that sine theta should be equal to the velocity of river divided by velocity of boat in the river. So this is how the sine theta goes. And how long it takes? This much it takes time to cross it, right? So that means from here you got this theta, or at least you can say T, which is 12.5 minute. This is going to be D divided by, in general, it's a VBR cos theta. So point is, from here you can get a relation. T is known to us. You can get another relation between D and VBR, and this is one relation between D and VBR, and theta can be borrowed from here, so that everything will be D and VBR. So two equations, two unknown, can be solved to find the width as well as VBR, and this you have already calculated by using this expression, right? So this can be handled in that way. Now let's talk about the question number 24. It says a butterfly is moving with velocity this, and wind is also blowing. So whenever wind is blowing, butterfly is moving. It's just like a boat in the river and the river. So you need to go with respect to ground. So what will be the total velocity of butterfly? So that is B. You need to add them up. So this is going to be 10 I cap plus 12 j cap. So that is its velocity. But the wind will take that butterfly in its own direction, and this is u I cap. So total component of this u direction will be coming as in x direction it will be coming as 10 plus u, and the velocity component in the y direction will remain 12. And if this is the angle, so that's the resultant direction. So you can say this 1037 degrees should be equal to 12 divided by 10 plus u. You can simplify to find the value of u. Question number 25. It says raindrops are falling vertically downside with this velocity related to the air, but air is also blowing towards east. So you can say velocity of rain, for this case, velocity of rain, if you consider, is going to be 10 downside, 20 meter per second downside and 15. So if I draw this picture format, so this will having a velocity component 20. This will be the velocity component 15 for the rain. So this is for the rain velocity, raindrops. What about the person? What the person is doing? The person is also running in this direction with velocity 5 meter per second. 5 meter per second. Then you need to find the velocity of rain with respect to man. So you need to reverse and supply it to this in opposite direction, right? So with respect to man, this will become this 5. So in nutshell, it will come like this is 10 and this is 5 at 20. Now you can find this is going to be the direction of, you can find this is the direction of raindrops. So from the vertical, what angle it should make, you can find it out. Because if this angle is alpha, then you'll find this is going to be alpha. So 10 alpha is going to be this divided by this. The way we have done earlier question as well. Now come to the question number 26, and let me give you a hint. It says find the acceleration of movable pulley. So this pulley is movable, and if the block B, and B, we need to find the acceleration of these two. Acceleration of A is given to us. So this A block is moving downside, right, 1 meter per second square. So we need to find the acceleration of another aspects. That means of pulley as well as this part. So what we can do for this thing is you can say first of all make the constraint relation, and this is, let's say, AA. Then find this acceleration B. You can think of, let's say, this is moving upside direction, so that is A B. Now you can write summation T dot A for these two. That means for block A and for block B. So that's T dot A for A, then T dot A for B. This must sum up to 0. So you can find this tension. Let's say start with this. This tension is T. So this will have a T tension up to this point. And better would be we consider it as a T. So let's say this is a T. So this is going to be T, T and T. So this will be T, this will be T. So it will pass on this as a 2T. So this will have a 2T. So this also will become 2T. Right? So you'll find this becomes 2T and this becomes T. Now you can apply the constraint relation. From here you will be able to find the acceleration of block B. Now how to get the acceleration of this hanging pulley? For that sake, we can use length of the string, as well as we can use this summation aspect as well. So let's see how we can perform that. So we can find the acceleration at any point. For that sake, what we need to do, we need to imagine or cut that string from that point. It will work. So let's say we are interested to find the acceleration of this point, right? So this pulley will be moving with the same acceleration this thread is going to move with. Now you can consider this part and apply the same formula, or you can consider this this part will be sufficient because B acceleration we have calculated. Now this has a tension 2T we have already talked about, and we can consider the acceleration of pulley like this, and you can apply summation T dot A for these two elements so that we can get the acceleration of that pulley. Or we can directly say that this point will have the same acceleration as the pulley, because pulley will be, if it is moving like this, so this point has to go there, right? If it is moving down, so this point has to go there. Same string, same string, same string, same string, same string. That means it will be connected with this, and will be this pulley will be moving with or accelerating with the same acceleration as that of this A. Right? As far as B is concerned, you can calculate from here how that B is going to go, or going to be equal to. This can be found out easily by this. And if we write this answer, we can write it quickly. It's going to be minus twice T into AA plus T into AB is equal to 0. So what this AB is coming? Acceleration of B is twice time acceleration of A, and A is given as 1, so that becomes 2 meter per second square. So that acceleration is twice of that of A, and it's going to be upside because this came out to be positive. So whatever the direction we opted is the correct direction. Now let's solve this question number 27, which is the last question of this exercise, and this is based on the relative motion, or the constraint motion you can think of. So it says block B moves with velocity u related to the wedge A. So that's related to wedge A, and this is moving with velocity v as shown. Theta is given to you. We need to find theta value so that it moves vertically upward with respect to ground, or vertically rather with respect to ground. So we can go for the relative motion, and we can think of this. Let's make these two components of this velocity so that it will be easy for us to work for. If it is theta, so that's going to be theta. So it becomes u sine theta, and that will become u cos theta. Now this u is the velocity related to the wedge. So what we are going to write, it is a velocity of A with respect to ground is vi cap. So this is I cap. We are using direction in the wave views y and x, and the velocity of B as seen from A with respect to wedge is given as this velocity. So this will be written as minus u cos theta in I cap plus u sin theta in j cap, isn't it? We need to find the velocity of B with respect to ground. So velocity of B with respect to ground is going to be equal to velocity of B with respect to A plus velocity of A. This is the relative velocity formula. VBA is equal to VB minus VA. That's what we are using. So we need to use these two, or we need to add these two together. When we are going to add them, so we are going to get V minus u cos theta. This is going to be in the direction of I cap, and plus u sin theta, that is going to be in the direction of j cap, isn't it? Now it says it should be moving vertically. That means x component should be 0. So for this motion, x component should be 0, velocity's x component should be 0, so you make the 0. Once you make the 0, so you get V is equal to u cos theta. That means what theta should be equal to. So cos theta should be equal to V by u. From here you can write theta is equal to cos inverse V by u. So this is how you can find the theta, so that it B moves vertically with respect to ground. Okay. So in this first exercise, I have given you a hint for all the questions, and you must try those questions if you have not tried yet. Even if you have tried, you can try them again, so that you can get your answer correctly and quickly, and that will be helping you in practice part of this physics. In the upcoming video, we will be talking about the further aspect of this. So thank you all. Have a great time.